Okay, the last type of angle that we're going to cover in Chapter 11 here in 21st century geometry are the angles that are formed on the outside of a circle. Now, these angles can be formed either by two secants or by a secant and a tangent, or they could be formed by two tangents. But whenever an angle is on the outside of a circle, it is equal to half the difference of the two arcs. So for example here, if I'm looking for the measure of angle A, the two arcs associated with angle A would be this one and this one. So the measure of angle A will be half, and you have to take the larger arc first, so the measure of arc CE, and then subtract the measure of arc B to D. So difference means we subtract. Now if we're looking at this middle example, where we have a secant and a tangent, then the two arcs that we would be interested in are this arc and then this arc out here. And again, because it is an outside angle, it's equal to half the difference, so it's going to be 1/2. The larger arc is the one further from the angle, so the measure of arc B to D minus the measure of arc B to C. And finally, this last example. The last example, we have an angle on the outside again. This time it's formed by two tangents. We still do it exactly the same way because it's an outside angle. The two arcs associated with this angle would be these two arcs. And I would have the measure of angle A would be half. The larger arc would be that major arc. So the measure of arc BDC minus the measure of arc BC. You always have to take big arc minus small arc. So let's take a look at calculating some of these outside angles. And I think we have about 9 examples here. So here we go. Clearly it's an outside angle. So it's going to be equal to half the difference of the arcs. Difference means we're going to subtract. It's going to be important that we can actually determine what the arcs are. So here's our angle right here. I'm going to call it X. The two arcs we're interested in are this one and this one out here. So our angle X is going to be equal to half, and then I have to take the big arc minus the small arc. So X would be half of, if I take 140 minus 66, I get 74. So my X would be equal to 37, and that would be the measure of angle KLM. So it's kind of like what we did when we had the two chords, except there we added the two arcs together. Let's do another example. Here's a second example. So the angle we're looking for, I'm going to label it with an X. The two arcs, well, here's one of them right here, and here's the other one out here. Now, unfortunately, they didn't give us that second arc. So we're going to have to calculate that second arc. This one out here. Now to calculate that, I'm going to take the full circle, which is 360, and I'm going to subtract 88, and I'm going to subtract 62. So if I take a full circle minus 88 minus 62, I find out that that arc out there is 210. And once again, the angle is equal to half the difference of the arcs. So So the angle is x. The big arc was 210. The small arc was 62. So x would equal half of 210 minus 62, 148. X would equal 74. So the measure of angle ABC equals 74. Let's do a third example. Now this third example, we have two tangents. That's still an outside angle. So the angle equals half the difference of the arcs. Well, they gave us one of the arcs. They gave us this arc right out here. We're looking for the angle X right there. We're going to need to find the arc right here. Now to find that, I will take 360 minus 313. I get 47. So my angle was X. My big arc was 313. My small arc is 47. So my X equals half. 313 minus 47, 266. Half of 266, 133. So the measure of angle PQR, 133. Okay, so we've done one of each type. Now let's take a look at a few more examples. So in this example, we're once again looking for the angle. I'm going to call the angle out here X. They've given us one of the arcs right here, 67. But I have to find the other arc right there. So I'm going to have to find that Y. Now, to find arc Y, the whole circle is 360. I'm going to subtract the semicircle, which is 180. I'm going to subtract the 67, and I'm going to subtract the 94. And I find out that the angle Y is 19 degrees. And now the angle is going to equal half the difference of the arcs. So the angle, which I called X, is going to be equal to half the big arc, which was 67, minus the small arc that we calculated was 19. So X is going to be half of 48. X then is 24. So the measure of angle BCD is 24 degrees. Always have to know the two arcs associated with the angle first. Okay, let's try another one. Now, this time it's a little bit different because this time we're looking for the arc. The arc S to W. So the arc we're looking for is this arc out here. I'm going to call that my X. I do know the other arc. I know this arc. And I do know the angle. And remember, the angle is equal to half the difference of the arcs. And this happens to be the big arc. So the angle, 40 degrees, will equal half of the big arc minus the small arc. And as we've seen in the previous examples or the previous sections, the best way to handle this, what I've encouraged you to do, is to multiply both sides by 2. That would give us 80 equals x minus 75. Then we'll just add the 75 on both sides. X would equal 155. So the measure of arc S to W is 155 degrees. Seventh example. Again, looking for arc. And the arc that we're looking for is from Q to U. And that's our X. We have the other arc. And we have the angle. So when I set it up, I would have 35 degrees equals half the big arc minus the small arc. And just as we did on the previous problem, we'll multiply by 2. 70 equals x minus 46. We add 46 on both sides. 116 equals x. So the measure of arc QU is 116. So when we're looking for the arc, it's really not much different than when we're looking for the angle, just a little bit of difference in how the algebra turns out. Number 8. Okay, number 8, as you can see, we are looking for an arc again. So I'm going to call that arc X. The one we're looking for then is this one right here. We have the larger arc out here. We're going to set it up the same way we did before, but this time, this is the small arc. Here's our angle. The angle equals half big arc minus small arc. So the angle, the 56, will equal half, and the big arc is 160, and the small arc is, well, the small arc this time is our X. To solve this, we'll multiply both sides by 2. 2 times 56, 112. On the other side, I get 160 minus X. And now I will subtract 160. 112 minus 160 gives me negative 48 equals negative X. I'll divide by negative 1. X equals 48. So the measure of the arc M to K, 48 degrees. One more example. So when you look at this example, you can see that we are once again looking for an arc. The arc we're looking for is from E to F. So this time we're looking for this arc out here. That's what we're trying to find. But in order to find that one, I think we'll first have to find this one. So we're going to find arc Y first. And to find arc Y, we're going to say 77 degrees equals half 191 minus the Y. We'll multiply by 2 on both sides. 2 times 77, 154. On the right side, we have 191 minus Y. We'll subtract 191 on both sides. We end up with negative 37 equals negative y. We'll divide by negative 1. So y comes out to be 37. But now to find the x. To find the x, the whole circle is 360 degrees. So x will equal 360 minus 37 minus 191. So x will be 132. So the measure of arc EF equals 132. Now that's the last example for this one. So